We are daily producing 2.5 billion gigabytes of data, and this number is increasing yearly. By 2025, humanity will generate around 33 zettabytes of data, which is a huge number. It is 3.3 followed by 22 zeros. It is hard to imagine this number. The problem with this insane amount of data, which is increasing daily, is where to store it. Much of this data is stored in enormous facilities known as exabyte data centers, which can be the size of several football fields and cost around $1 billion to build and maintain. Another concern is how to store the data for a longer period of time. Fortunately, there is a smart solution. Scientists suggest to store the data in the DNA, as the DNA can store the data for thousands of years or even much more, and the DNA is a very dense storage medium. For example, 1 cubic inch of DNA can store 1 exabyte of data. And the most important thing, it doesn't need an enormous buildings as the existing data centers, which need a huge amount of power. Now, we want to emphasize that the used DNA is synthetic. There is no organisms or life. It's just a DNA used as a medium. So let's see how storing data in DNA works. Digital storage system encode text, photos, or any kind of information as a series of zeros and ones. The same information can be encoded in DNA using the 4 nucleotides that makes up the genetic code A, T, G, and C. For example, G and C could be used to represent 0, while A and T represent 1. The major bottleneck in using DNA to store data is difficulty in picking out the file you want from all the others. DNA file conventionally retrieved using PCR. Each DNA data file includes a sequence that binds to a particular PCR primer. To pull out the specific file, the primer is added to a sample to find and amplify a desired sequence. Currently, there are many research teams and companies are working on this technology in order to overcome all the obstacles. One of these companies is Microsoft, which is working with the University of Washington, and recently they made a breakthrough in using synthetic DNA for data storage. This technology is very promising, and don't be surprised if one day the world's most valuable archives find a new home in a poppy seed-sized collection of molecules. Thank you so much for watching, and I'll see you in the next one.